Welcome to our YouTube channel where we give you nothing but the very best in terms of academic services. My name is Mr. Kasov, and please don't forget to subscribe to our YouTube channel. It's KZV Academics, and also like and follow our Facebook page. It's KZV Academics. You can also email us on kzvacademics@gmail.com or call us on 0962 38 0108. Remember that ours is progress. So today we are looking at geometric progression, and we need to understand what a geometric progression is. So first thing first, we define what a geometric progression is. What is a geometric progression? So this is a sequence in which each term is formed by multiplying each term by a constant amount. Now that constant amount is known as a common ratio. For example, let's say we have a sequence. Your name is Jennifer, right? Jennifer. Beatrice, okay. Beatrice, look at A. There, that is a sequence, 4, 12, 36, 108, and so on and so forth. Isn't it? This is a GP. It's a sequence that is in form of a geometrical progression. For us to find 12, we need to multiply by a constant amount, and that constant amount is what we call a common ratio. Okay. Now the constant amount is a common ratio, but how do we find the common ratio? So number one, let us find the common ratio. Common ratio, which is denoted by R, is given by T2 over T1. In this case, our T1 is 1, here 4, our T2 is 12. So we say 12 over 4, and what we get is 3. So our common ratio is 3. Now, what is our first term?
First term.
Yes, our first term, which is denoted by A, is 4. Is that okay? Yes. And then they are asking us to find a formula for the nth term. How do you find the formula for the nth term? Now, the formula for the nth term is given by Tn is equal to A r to the power n minus 1. What is our A? Our A is 4. What is our R? Our R is 3. What is our N? N is the nth term. So here we say our A is 4 times, this is 3 to the power N is, and then minus 1. Okay? So our Tn is equal to 4 and then 3 to the power N minus 1. Is that okay? Yes. So if they ask you to find the nth term of a geometrical progression is formed by finding where you multiply, each term is multiplied by a constant amount, which is a common ratio. So the common ratio is 3. 4 times 3, we get 12. 12 times 3, we get 36. 36 times 3, we get 108, and so on and so forth. So this is a definition of a geometrical progression. Now, if you want to find any term, for example, this is 1, 2, 3. Our set term is 36. We can use this formula for Tn is equal to 4 and then 3 to the power n minus 1. Suppose n is 3. Then we'll say T3 is equal to 4, and then I put 3 there, and then n is 3 minus 1. Hi. So here I'll say this is 4, and then 3 minus 1, I get. Now here I have, this is 4 times, 3 times 3, it's 9. 4 times 3, what I get is?
4 times 3.
Yes, 4 times 9 is 36. And you can see that this is T3, our T3 is 36. So this is a formula for finding the nth term. Okay, so any term, if T4, we just substitute there. T1, T2, T3, T4, depending on your n. Okay, let's go to B. Same example there, we go to B. So B, we have 256, and then we have 128, and then we have 64, and then we have 32. Now the question is, find the formula for a GP. Find the formula for finding the nth term of a GP. For each of the following GPs, find the formula for the nth term. Now remember that the nth term is given by Tn is equal to A r to the power n minus 1. What is our A? Our A is 256. What is our R common ratio? Our common ratio is T2 over T1. Now, what is our T2? Our T2 is 128 over our T1 is 256. Can you reduce this? Or you can use a calculator. This one is the mathematics paper 2. So you can use a calculator. There's no harm. So 128 over 256. What you're getting is 1 over 2. Okay? So here 128 into 128 is 1. 128 into 256 is 2. So what you get is 1 over 2. That is our R. Now we substitute there. We'll say Tn is equal to, what is our A? Our A is 256, okay? And then what is our R? Our R is 1 over 2, and then to the power n minus 1. Is that okay? Now we go back to indices on the negative index. Negative index. So if we are given x to the power negative m, it's the same as saying 1 over x to the power m. Okay? Are we on the same page? Huh? Okay, so if you look at this one here, this 2, 1 over 2 is the same as saying 2 to the power negative 1. Do you agree with me? Yes. Okay, so here we can say 256, 2 to the power negative 1, and then to the power n minus 1. Do you agree with me? Huh? Yes. Now, from that point here, we can say this is the same as saying 256, and then power of a power, you multiply the powers. If you have a power, and then another power, you multiply the powers. So here you say this is 2 to the power negative 1 times n, you get negative n. Negative 1 times negative 1, you get positive 1. So there we have 256 times 2 to the power negative n plus 1. Now this 256, we can write it in terms of the powers of a prime number. What does it mean? In terms of the powers of a prime number, it means that we can write it in terms of a power of 2. Where we have a base 2, we say 2 to the power 8. 2 to the power 8 is the same as saying 256 times 2 to the power negative n plus 1. Now, under indices, if you are multiplying the same base, you add the powers. Whenever you are multiplying, according to the first law on indices, whenever you are multiplying with the same base, you add the powers. So in this case here, we'll say 2 to the power 8 plus negative n plus 1 there. Is that okay? Yes, implying that we have 2 to the power 8 minus n plus 1. So here what we have is 2 to the power, this is 8 plus 1 minus n. Okay, so what we get there is 2 to the power 9 minus n, implying that Tn is equal to 2 to the power 9 minus n. So this is the formula for finding the nth term of a GP for that example there. Is that okay? Yes. Now we go to example 2. You can write that one there.